perfectly inelastic collision. You might use the term plastic also. Inelastic stands for plastic. Here E equal to 0. And since you know this is equal to minus delta V upon delta U, you get here delta V equal to 0, and delta V is nothing but the difference of two velocities that you call relative velocity. V1 minus V2 equal to 0 simply concludes that V1 equal to V2. Now, what does this result stand for? You are getting the result that both the bodies will have the same velocity when after collision. If after collision you see two balls collided this way and they are having now the same velocity, this means they are going together now, means they will stick together. That is one and only indication for this inelastic collision, that whenever the bodies collide in this manner, they will move together as a single body. This is the only criteria, or you might say acid test, for checking the nature of the collision. If the bodies are moving together, you will immediately claim that it is inelastic collision. For example, I tell you one sand bag that's hanging from the ceiling, and some fast arrow gets pierced in it, comes and gets pierced in this. Now both will move together. That arrow won't be able to cross this sandbag. So it gets pierced and they move together. This is the type of perfectly inelastic. Here, the two bodies having velocities given, they collided, moving together. So momentum conservation requires that the sum of the two momentums shall be equal to final momentum. And this is the common velocity for both the objects moving together after the collision. Then there comes imperfectly elastic collision. You must remember in this type that we just covered, in this type there is maximum loss of kinetic energy. Maximum loss means simply the kinetic energy is getting converted into heat, light and sound, etc. Third type, that is more practical. Perfectly elastic collision is possible between fundamental particles. This is possible when the two bodies stick together like wet clay balls. If they collide, they will stick together. This could be the example. But the more practical and very frequent in nature is in between, that is neither perfectly elastic nor perfectly inelastic. That's known as imperfectly elastic collision. For imperfectly elastic collision, E lies between 0 and 1. 0 and 1. So we have one equation in terms of velocity. E must be known for this type, that is going to lie between 0 and 1. And the other equation shall be that of momentum. m1u1 plus m2u2 will be equal to m1v1 plus m2v2. You have two equations at your disposal, and with the help of these two equations, you can solve the problem given. Finally, you see, so far we have been discussing all the collisions which were along one axis only. These are termed as 1D collision. But suppose it's not the type, means 1D you say only when all the velocities, you are having 4 velocities for the collision between two objects, 2 initial and 2 final. If all the 4 velocities are along the same axis, you would call it 1D collision. But if these velocity vectors require more than one axis, it would be called 2D collision, means collision in plane. Here we need two axes for representing their velocities. In such cases, we call it oblique collision also, because the possibility of a bit rotation is also there. So what we do in such cases, we apply the conservation of momentum axis wise. Means we say that whatever the momentum was before collision along x-axis, that will remain same even after the collision along x-axis. This equation has been written here, you see. Similarly, along y-axis, the momentum that we had before will remain even after also. So in this two equations, we solve separately considering the direction.